Okay, so now talking about future exponentials and the future being exponential, let's unpack this term a little bit. It's kind of weird term, but if you think back to your Math 101 class, you'll find that exponential trends doubling every time period. If you meet that out, it's going to always look something like this. So instead of going 1, 2, 3, you go 1, 2, 4, 8, and so on and so forth. And probably one of the most important and well-known exponential trends in the world of technology is known as Moore's Law. Moore's Law, this is Gordon Moore, co-founder of Intel. 50 years ago, he formulated a law that is called the that was named after him, Moore's Law, which says that in the last 10, he noticed that he published in a paper actually, he noticed that the number of transistors per square inch in integrated circuits was doubling every year. And then he predicted that's going to be true for the next 10 years. And then he revises for observation to be true, to be doubling like every 2 years. And this has been true for the last 50 years. Like for example, if you can put a transistor now per square inch, next year that's going to double. So you can put 2 transistors and then 4, and then 8, 16, 32, and so on and so forth. And that has been true for how long? 50 years. So that's called Moore's Law. So to make this a little bit tangible and to give you an idea of how this looks like, this is ASCII-Red. ASCII-Red was commissioned to, in 1997, cost $55 million. That was one of the most powerful computers that was commissioned to Sandia National Laboratories. They did atomic weapon testing using this thing. This computer here was the size of a tennis court, okay? And it was one of the first computers that broke through 1.3 teraflops. That's 1.3 trillion floating point operations. So if you want to have a sense of that, imagine that you would do 1 trillion. Trillion is 1 million millions, 10 to the power 12. So imagine that you would do 1.3 million mathematical operations like addition, adding 2 numbers, 2 and 2, in your head in 1 second. Imagine that that's what this computer could do. So 1.3 teraflops. So that was ASCII-Red, 1997. 9 years later, you walk into Best Buy, you buy PlayStation 3, which was commissioned by the end of 2006, cost you $499 with 2.1 teraflops. That's even more compute power, okay? And so you go from something that you deploy to do atomic weapon testing with to something that you can play and destroy the earth on a big screen television. So you go from something from $55 million, 1.3 teraflops, to $499 with even more compute power. And there's a different way too. This guy here is called the Pi Zero. This is a full scale. By the way, this is a full, which was released by the end of 2015, which is a full scale computer. It is the size of a credit card. Can you imagine that? Which you can plug to a monitor and a keyboard, and you can put some RAM in, and you can run Windows on this thing. Cost you how much? $5. The compute power of this guy here is literally what you get for the price of a large Starbucks latte. Gets you 2.5 Cray 1 supercomputers. Each one of those has more compute power than NASA has to put the man on the moon. So with $5, you buy the Pi Zero, whose compute power is equivalent to 2.5 Cray 1 supercomputers. Each one of those has more compute power than NASA has to put the man on the moon. And then you get super, super small. This is a golf ball here. This processor here is 2 millimeters by 1.6 millimeters. Okay, the compute power of this processor here is better than early stage Pentium processors. This processor here and many other processors like it is the sole reason why everything is going to be smart. No question about it. So what I'm trying to say is that computing gets two interesting ways. It gets incredibly powerful and it gets incredibly smart. Okay, and now it's also important to understand that exponential trends are not only happening to computing, it's also happening to many other industries. For example, the number of internet-connected devices. Okay, in 2003, we had 500 million internet-connected devices. In 2012, that number went up to 8.7 billion internet-connected devices. Today, in 2017, we have 28.4 billion internet-connected devices. By 2020, that number is going to rise up to 50 billion internet-connected devices. By 2030, we're going to have 1 trillion internet-connected devices as we information enable every aspect of life by the Internet of Things, the IoT. Can you imagine the phenomenal amount of information that is going to be available out there when we are going to have 1 trillion? Trillion is like 1 million internet-connected devices. Okay? That means that we're going to witness an explosion in the rate of innovation as millions of new innovators will start to experiment and upload their businesses, services, and products and launch their new businesses online. If you think that the rate of innovations have been fast in the recent years, well, let me be among the first to tell you that you have not seen anything yet. A world of chaos and amazement is still ahead of us. We are just 1% down this road. Okay, by 2030, we're going to have 1 trillion. Now we are 50 billion. If you divide 50 billion by 1 trillion, it's like 1% or 2%.